The University of Canterbury are working on state-of-the-art quake-safe bridge technology.
It's a leading design for the future of quake-safe bridges, testing how their strength and structure holds up during earthquakes.
This means that we can't control the earthquake, but we can control the structure.
What you see here is a half-scale bridge being pushed and pulled, as it would when a quake hits. But the difference between this design and many of those already built is the foundations. They're not locked down and move with the shaking ground.
It means it protects your column, so you see that there's nothing happening in the column, it's just the column rocking normally. But if you're trying to prevent that movement, like the way that we do in traditional design, that we're locking it with the footing, at this movement you will see lots of cracking happening in the columns.
The new technology also means the entire bridge would be fitted with large rubber bands, helping with the structure's stability.
And so these rubber bands are pretty much providing self-centering capacity to the system. So that means that if, for example, we have an earthquake going in this direction, what's happening is that the bridge is moving like this as an articulated system. And if you look at the bottom of the column, you see that the column is rocking over this foundation pad.
Dr. Alessandro Palermo is leading the research, along with a team of the Canterbury University students and trade staff. They have just 1 year left of their 4-year project and hope to see the state-of-the-art technology on land by the end of next year. Dr. Palermo believes building bridges that survive earthquakes barely unscathed will help immediately in the aftermath for residents.
If we have a bridge which doesn't have damage after the earthquake, that means that we don't have to close the bridge even for 1 week. That means that you can drive easily and you don't have to worry to do a detour and go in another part of to go to that part of the city by doing a different route. So that is what we are aiming for.
Having first-hand experience of quake-damaged bridges in Christchurch has aided the students' findings to create the best technology.
I can see the damage in the structure and then I can correlate and support it based on my knowledge and justify it in some way, you can say, by the numbers. But imagine yourself that the building or the bridge hasn't gone through any earthquake and you're coming up with numbers for it, that this is the capacity, here's going to be the deal. I think most of those things will be based on theory only. You need to have some experimental investigations to back up your conclusions.
How these bridges hold up during an earthquake will lead the way for bridge designs around the globe. Emma Cropper, CTV News.